Okay, so we're just going to focus on 6 markers in this walking, talking 6 marker mock. So this first one is quite a nice one. When you look at these questions, you can probably figure out quite quickly which ones are targeted at grades up to C and which ones are targeted at grades up to A star. And this is one that's targeted up to C, so everyone should be able to get really good marks on this. So we've got Tim walking on a nylon carpet and he wears shoes with rubber soles. Okay, when he touches a metal rail, he feels an electric shock. Tim is worried about the risk from these electric shocks. And again, as with a lot of OCR questions, okay, we've got an actual question beyond the question stem, which is explain these observations. So you've got one thing to do there, and you've got another thing to do, and that other thing is to discuss what Tim will need to consider to decide the size of the risk. So there's not actually that much you can write about the electric shock and why it happens, okay, so that's why they've put in this extra bit. So what we'd probably do is we'd probably start and brainstorm it. I'll just do it on here, you'd probably do it in the corner. So we'd have a think about what we can do as the observations. So first thing, I'd start with something quite simple, and I'd name what this is called. So it's not mentioned that word, so we can assume it's probably going to be a keyword in the exam. So if there's something that seems obvious but it's not been mentioned, you're going to mention it. Next thing, we're going to think about why it happens. So we'd probably mention electrons, the fact that these are transferred, and we'd probably be mentioning insulators, because that's when we get a build-up of static charge. Okay, so next thing, we've got a metal rail, so we might be mentioning conductors. So we've now got probably most of our keywords, and then we can use that to build an answer, and that, that might take you 30 seconds. Then discuss what Tim will need to consider to decide the size of the risk. Okay, so what we'd maybe do is we'd maybe think about, I don't know, how dangerous it is, so that the kind of like likelihood of the risk occurring, and what we call a severity. And then we'd have a think, so likelihood, well, it's highly likely it happens all the time. Severity, well, most people are going to be absolutely fine, but maybe there are some people, particularly with heart problems, who might struggle. So then we can probably explain the size of the risk and what Tim needs to think about. But again, we're not having to give massive detail, we're not having to give massively complex answers, because it is targeted at C grades and below. This next one then is a much harder question. It kind of requires you to have explain knowledge from several different areas, so it's targeted at ASR students or up to them. So it gives you a passage. Okay, a study for the German government was carried out by scientists from the University of Mainz. Found that children living within 5 kilometres of nuclear power stations were 2.19 times more likely to get cancer than children living further away. Researchers looked at a sample of 593 children under 5 who had leukemia, which is a type of blood cancer, over a 23-year period. They compared them with a sample of 1766 children, healthy children, sorry. For each child, the researchers took into account the distance from the child's home to the nuclear power plants. Some scientists think that emissions of ionizing radiation from the nuclear power stations could be causing cancer. Other scientists think that the increased risk is due to other factors. Okay, so we've got a lot of information there, and then we've got even more. This is quite common with some OCR questions where they may be struggling to get enough science out of you. They're going to give you a lot of information to interpret. So we've got Norrie. We should close down all nuclear power stations as they clearly cause cancer. Good alliteration, Norrie. Nick has appeared as like various characters in OCR papers. He was, I think, Rajesh at the beginning. Nick, we can't be confident about this study. We should think carefully before making any new laws. Okay, and then we read the actual question. So we've taken all this information. I'll read the question. So, use ideas about the harmful effects of radiation together with information about the study to discuss whether ministers should write laws based on this study. So this one we've kind of got three things we can be writing about. So we'd start off with the harmful effects of radiation, and for this bit we would probably be keeping it quite simple. So we would mention the effects of ionizing radiation and maybe how it can cause cancer. The stylus is rubbish. Then would go on to information about the study. Actually, no, we might do. I'm just thinking we might get a bit more in here because just making one point probably isn't enough. So, harmful effects of radiation. We could talk about. I think this has been common in a few papers that we've done before. Contamination, irradiation. Could talk about maybe ionizing power or penetration. Of alpha, beta, gamma. And then we'll have definitely covered that. Information about the study, so that is going to take us back to this top bit. Okay, so what we'd probably be thinking of there is what can we pick out that tells us the study is either a reliable study or an unreliable study. And for this we're almost going back to the case study that the core and additional students have done. So to me I'd be looking at this kind of thing, and here I'd be looking at here, and I'd be looking at here. So we can then say certain things about these. So we can say something about the sample size, we can say something about the length of the study, we can say something about the university, and we can say something about the German government, and all those things help us. Then finally, and we've got to do quite a lot to get our marks here, whether ministers should write laws based on this study. So we'd have to consider essentially some maybe some pros and cons of closing nuclear power stations. So, it might be that it eliminates these higher levels of cancer, but it might well be that it's something else that's causing it, and we could write about that. And then we'd think of some cons of closing nuclear power stations, so what problems they may have. And if we do all those, we should definitely get 6 marks, but you can see it's quite a complicated question. But not to be outdone, this is an even more complicated question. So we've got This one's from P4 now. Last one's from P6. So look at two graphs, and it's showing motorcycle rider death and helmet use. So the first thing I do is kind of annotate these. So kind of got a period where it's going up here, period here where it's going up, then down, then up, and then down again. So there's kind of got fluctuations here, and that's the percentage who used helmets. So maybe with advertising campaigns, people, the percentage increases, and then maybe it decreases, and then increases again. Personally, I've never really seen any motorcycle riders not wear helmets. I don't know what they're doing now. Next one is motorcycle rider deaths per year. And you can see it's a bit clearer, this one. We've got a general trend up, and then more recently, 2007, 2009, it appears to go down. So we've got two quite different graphs. There doesn't seem to be any obvious correlation there. And then a politician looks at the graphs, and he says the number of deaths dropped in 2009, and that year fewer riders used helmets. We think motorcycle helmets save lives, but this data proves they do not. The scientists wouldn't use that word proves. I think that motorcycle helmets stop your head moving in a shorter time during a collision. And then again we have a bit more information. We haven't got to the question yet. So the politician has misunderstood the ideas of correlation and cause and does not understand how motorcycles work. Explain why he is wrong using the data and your knowledge of physics. So again, we've got two areas here. So he doesn't understand the idea of correlation cause, and he does not understand how motorcycle helmets work. So we've got two things to address. And again, it's probably worth doing them in sequence. So on this one, we'll start off with the idea of correlation and cause, and what we want to look at is, firstly, is there actually a clear correlation? I'm going to have to come to a conclusion on that. Is the correlation that he talks about, is it consistent over the time span? Okay, so we'd want to know, is it consistent? And then he says it proves they do not. And all we see here is a correlation. So we'd want to discuss the difference between cause and correlation. And what I'd probably do then is maybe think of a plausible reason for why we did get this drop of people who died. It might be as simple as there were fewer cyclists. Just remember, this only shows the percentage who used helmets. It doesn't show the number who used them, it's just the percentage. And then we'd move on to the idea that he doesn't understand how motorcycle helmets work, and we'd want to link that to an equation, and the equation is to do with change in momentum. And it links to force and time, and it's exactly the same. You can always write pretty much the same answer as when we're describing seat belts and what they do, crumple zones on cars, that kind of thing. So we want to explain it in terms of change in momentum and force and time, because he isn't able to do that. Okay, on to our final one. Okay, and finally we come to this one. This is actually it's the question with the easiest wording, but it's targeted at the highest grade. This one's targeted at up to a star, because this is just testing pure science. It's a nice one. Okay, so some scientists believe that nuclear fusion will be a major source of energy. Currently, nuclear power stations use nuclear fission to generate electricity, and then it's got a comparison of the energy released per event, and it wants you to compare how nuclear fusion and nuclear fission release energy. So again, classic OCR, we've got two separate things that we're going to be writing about. So I would again split it into two. Probably start with fission, maybe slightly easier, and then move on to fusion. And I'd try and come up with as many keywords as possible that will help us with this. So thinking about fission, we'd be saying things like neutron. Would be using words like split. Would be using words like unstable. Would be using words like smaller nuclei, maybe. We might be talking about a chain reaction. I mentioned uranium. And we might be mentioning about like more neutrons released. And that's quite a lot. Okay, so then we'd think about fusion, and we'd have to talk about hydrogen nuclei. We'd talk about them combining. Talk about how it requires very high heat, so it's high temperature. I would maybe write about the outcomes. So I would maybe think, well, helium forms if we eventually we'll fuse hydrogen and then fuse that to make deuterium and tritium, and then it would make helium. And then we might think about how that happens, and the crucial thing is that equation that's given, which is E equals mc squared, and we can maybe explain that. So mass is lost, and that loss of mass gets converted to energy. And this releases a lot of energy, okay, or really a lot. Okay, so this is just pure science. It's a nice question. What I've got to make sure is we're getting in enough about these two, and we're trying to get in this really high level content that's going to assure us of 6 marks out of 6.